Hi, in this video we are going to learn multidimensional scaling. In short, it is also called as MDS. MDS is largely applied for marketing research because it provides a map in that different things can be overlapped. We have already learned how to position these 12 products based on their similarities or dissimilarities. Factor analysis can help you, or correspondence analysis can support you. But more typically, when you need to position variables, such as these products, based on their conceptual dissimilarities or similarities in a reduced number of dimensions, the MDS might be the first answer. What does a reduced number of dimensions mean? The initial number of dimensions equal to the number of items we compare. In this case, we start with 12 dimensions. The 12 dimensions can exist conceptually, and you don't need to visualize it. But when we need to visualize the conceptual distances among 12 items, we need to reduce the number of dimensions. During that process, you can guess that you should accept some errors that are occurred while we are reducing the number of dimensions. But as far as the error size is acceptable or marginal, we can successfully reduce the number of dimensions even up to 3 dimensions or 2 dimensions. Then, finally, we can visualize the result with one chart, and particularly on a paper. Actually, that is the process or procedure and the principle of an MDS technique. Then before we look into the MDS technique, let me explain you about the stress value first. The stress value in MDS indicates the badness of fit between conceptual distances and calculated distances. The calculated distances actually means the plotted result. And when the number of dimensions increases, the stress value will decrease. As I said, the initial number of dimensions equals to the number of objects you want to calculate the distance. While reducing the number of dimensions, you need to optimize their distances, and by doing so, an error or stress will occur. Despite of the increase of a stress value, it is more proper to pursue a less number of dimensions as possible. Otherwise, it is actually meaningless to perform the MDS. So when we look at the formula to calculate the stress value, the less it is, the better is the suitability. The conceptual distance, d hat, indicates the initial distance that existed before the number of dimensions is reduced. And the calculated distance indicates the distance after the number of dimensions is reduced. Therefore, when both distances are same, the stress value will be 0. And this means that it is a perfect case. Suppose you have color chips in a three-dimensional space. But for some reason, you have to crush the colors to be flat, which means you are converting a three-dimensional data into a two-dimensional data. For that, you should give up certain amount of information. Less dimension, but losing some data. So it is kind of a trade-off. So when the stress value is exceeding 0.15 or 0.2, then you better not reduce the number of a dimension, or your MDS is not really proper. So you should choose different method to display your items or your variables. In a social science study, including design, a minimum stress value can be 0.2. It is acceptable. In MDS, depending on what you want to visualize, you simply need to make up the data matrix. In SPSS, ALSCAL covers both square and rectangular shapes of a data matrix. When the data matrix is a square, it indicates not only the sizes of a row and column are identical. What it actually implies is that the contents of rows and columns are identical. Therefore, as written in the first row, when you visualize objects such as brands, products, or cases, you can have an input data matrix that consists of identical objects in both row and column. For example, this proximity matrix is the case. Other than that, the data of input matrix consists of two different substances, such as properties by objects, or respondents by objects, or respondents by properties, etc. Consequently, the shape of a data matrix is basically rectangular. So the multidimensional scaling is useful when we need to explore the conceptual similarities or dissimilarities in data, or when we need to visualize the relationship of the conceptual distances among independent variables or dependent variables, or even between independent variables and dependent variables. Going back to the example case, suppose you need to estimate the distance between the following 12 products. You need to know 12 by 11 divided through 2. So you need to know 66 distances. How you would answer to this question? I hope you still remember the proximity matrix learned from the clustering analysis. As you learned, a proximity matrix displays the conceptual distances between items. Suppose you have the assessments on these four products with regard to these three adjectives. Based on the Euclidean distances, we can estimate the conceptual distances. And you did already to answer to the before class quiz last week. So we know how to approach to answer to that question. We just need to think about what criteria should be proper to measure or distinguish the characteristics of each of the products. Once you have this proximity matrix filled out, you can continue to a square symmetric matrix. As introduced, MDS can be categorized based on the shape of input data matrix. When it is in a square shape, we call it square symmetric or square asymmetric. The difference of square asymmetric is the case when the conceptual distance between A to B and B to A is not equal. When it is a square symmetric, you need only the half of the data to give into the SPSS. If you still have the Excel data from week 11, let's perform a square symmetric ASCAL test in SPSS. I guess everybody has downloaded this Excel datasheet, and let me show you how to obtain the proximity matrix. So first we copy the data and we paste it in SPSS. And many of you used the clustering analysis to get the proximity matrix. That is okay. But if you only want to get the proximity matrix, then you also can obtain the proximity matrix from correlation analysis and then distance estimation, and you select all here and then OK. So here is the result for the proximity matrix. And let's copy this by clicking the right button and then copy. Let's paste it in Excel. A new sheet. So with this data, we are going to perform the square symmetric ASCAL in SPSS. So now I'm copying this data again. Then open a new data sheet and I'm pasting the distances here. And of course, this is symmetrical. And you can leave the copied dHalf as it is for the analysis. It's okay. And for square symmetric ASCAL, you click analysis and the scale, and then you will find ASCAL. You include all 12 products here, and in this shape of as a shape of the matrix, this is a symmetric square. You click, and for model, it is measured in interval scale. You can modify here, but I'm interested in displaying the 12 products into a two-dimensional space, so I leave as it is now, the minimum of 2 and maximum of 2. And for option, I would like to obtain the coordinate. Okay. Then OK. So here, fortunately, the stress value is less than 0.2. So it's not very nice, but it's still acceptable. So we can use the result even for the research article. And by the way, this RSQ indicates the reliability, and when it is bigger than 0.6, then you can conclude that your results are reliable, and it's bigger, better. In this case, it's a good or satisfactory size of RSQ. And so here, by double-clicking this very rough chart, you can decorate the colors or the size or change the typeface, but basically the 12 products are positioned in this two-dimensional space. And I guess the number 3 is the calculator, Dieter Rams' calculator, which is again positioned quite far away from the other products. We are familiar with this range from the vector analysis. Okay, and below the Euclidean distance model, you get a scatter plot of linear width, and ideally this scattering should be on a linear line, and if it's more clustered along the line, then it's better. But it doesn't give you any quantitative scale, so in MDS you just need to refer these two indicators that are more relevant. But when you have not yet calculated the proximity matrix, you can simply conduct a rectangular shape of MDS. This takes an input matrix that is assessing two types among objects, properties, and respondents. And this also results a coordinate matrix. Differently from the vector analysis, and both correspondence analysis and MDS requires the data input with a horizontal array of objects you are evaluating. Sometimes it is quite confusing what to array horizontally or vertically in SPSS, at least in my personal experience. And you don't know what method you will eventually apply to your study, so take it for granted that you rearrange or you will rearrange the data or transpose the data depending on the technique you will apply. And there will be not only one technique until you finish your analysis. And it is quite common to manage the data in Excel. You just copy the Excel data and paste them in SPSS. Okay, then using the data arrayed in this way, let's try to conduct a rectangular ALSCAL in SPSS. Now let's try to conduct a rectangular ALSCAL test. For that, we need to transpose the data arrangement. As you remember, we need a horizontal array of the variable. So first we select all, and in a new sheet, by clicking the right button, you get a special paste, and you click it, and then you click transpose. So now horizontally it is 12 columns, so 12 products, and vertically the 12 adjectives. Okay, so I copied these data in SPSS, a new sheet, I copy like this. So 12 products assessed by 20 adjectives. And then analysis, scale, in ALSCAL, select all 12 products, and it's rectangular. And number of rows is 20. Because it's 20 adjectives and we take all, right? And for model, it's again interval scale. And for option, I'd like to have the coordinate. Then OK. All right. Unfortunately, the stress value is exceeding 0.2. So we have performed the MDS, but the result is not satisfactory. So I'm not recommending you to use this data because it includes two big stress values, or it includes two big errors which we better not ignore. And here you see the fitness also shows a lot scattering tendency compared to the previous one. So because we have used the same data for the MDS, you can use a symmetric technique to get a better result. So as I have shown you, although you only have the same data set, you can try out different methods, and perhaps if you're lucky, then some may offer you a good model, while it's not always the case. So it's interesting to see that if you only want to display the 12 products here, then it's okay, the stress value is acceptable. But if you want to position the 12 products with 20 adjectives, then unfortunately we failed this time. So you can explore different techniques until you find the best one among them. In 2010, one student had a very clever idea to apply the MDS to her thesis project. She successfully validated the effect of her design. She proposed a fan that operates interactively. A pair of fan is owned by two people. When one is blowing the air into a fan, the other is receiving the air. She intended to make people experience the value of donation. In this case, donating blowing. Anyway, she tried to provide an evidence that tells her concept. For that, she divided people into two groups. Both groups were presented with a photograph of a fan. But the first group only watched the photograph, and the other group was presented with a video clip that explains the interactive function of the fan. These two charts present you how differently the two groups judged the value of the fan. Because the fan looks quite ordinary, the first group didn't have any doubt that the product is another type of a fan. Their conceptual position about the fan is nearby some air-related products. However, in case of the other group, they consider the fan is a kind of donation item. The conceptual distance between fan and charity items is shorter than that between fan and air-related products. By having added this validation, she could successfully deliver the design message in an objective way. I would say her approach is rather inventive. MDS more usually for spreading objects or adjectives or consumers into a 2 or 3-dimensional space being overlapped. But as she did, MDS has a great potential to get utilized for different purposes. For a case review, find a good article and try to answer the following 4 questions. Concerning the second question, it may not be an ALS call. MDS includes a lot more different techniques.